Hello everyone. So let's see the problem. The problem states an electron, a proton, and an alpha particle having the same kinetic energy are moving in circular orbits of radii Re, Rp, Ralpha respectively in a uniform magnetic field. The relation between Re, Rp, Ra is. The options are given as these. So let's see the solution. To solve this question, you need to have some derivation. You need to derive some relations. To derive them, we'll check the first equation, that is, for radius in a magnetic field, the formula is mv upon qb. That is, m is the mass, v is the velocity, q is the charge, and b is the magnetic field. Mv is also known as momentum, which is denoted by symbol p. Hence, the formula p upon qb. Now, the question states that all the particles have same kinetic energy. That means half mv square is a constant. When we replace mv by p, we get the following equation, p square by 2m, using which we can conclude that p is proportional to root m, as kinetic energy is constant. Putting this result in equation here, we get the following proportionality relation. Now this would be the primary criteria for comparing all our further cases. The first case are proton and electron. In proton and electron, the charge is same. Mass of proton is 183 times mass of electron, right? So when we put these two equations in this equation, in the above equation, the result is r radius of Re would be less than radius of proton, correct? So we are left with radius of proton and alpha particle. Coming to that, we know the charge on alpha particle is 2 times the uh, charge on protons, right? And the mass of alpha particle is 4 times the mass of proton. Thus, when we put these two values in this equation, above equation, we get Rp equal to R alpha. That is, radius of proton is equal to radius of alpha. Thus, the answer Re is less than Rp equal to R alpha.